We're live. Okay, so here we go. So today we're talking about vectors. And what we're going to do today is just draw vectors, okay? So first of all, there's a few things we need to know, okay? So, example 1. An airplane travels 400 miles per hour due north. That's its force, okay? It encounters a wind traveling 50 miles per hour due east. Draw a vector diagram and find the new speed, that's the magnitude and direction. Grab a ruler, okay? So first of all, I'm going to try and draw this scale. So I'm going to go north to sea. So I'm going to, right here, just put a point. That's my airplane. And using centimeters, I'm just going to go 4 centimeters. I drew it 4 centimeters. I drew it 4 so it'd fit on my paper, right? I mean, I'm not going to draw it 400 because I could draw it 40, but that'd be off my page too, okay? So, and then all of a sudden, the airplane, so what we're going to do is we're going to draw this head to tail. The head-tail method is the easiest way to draw it because then I get a 50-mile-an-hour wind. Now, if 1 centimeter was 100, right? If 1 centimeter is 100, I'm going to go half a centimeter. Call it 50, okay? So the airplane's really going this direction, right? This is what we call the resultant vector. Because it's the result. Now this is really kind of like a silly way to do it, but it's the easiest way to draw it. The way it should be drawn is more like this. And I will put it up here. Here's my, and you don't have to draw this, here's my 400. Here's my 50, because they're basically acting on the airplane all at once, right? It doesn't just go from 400 and then gets blown off course for 50. That's unrealistic. But this is the easiest way to draw it, is we call it the head-to-tail method. You can see the head-to-tail method. The other way is called the parallelogram method. So, and the resultant vector is there, okay? That's the parallelogram method. It's more realistic because both forces are acting on it as it's traveling, correct? This is easier to draw. Here, boom, here's my resultant vector. Okay, so now we haven't answered the question yet. This question says to find this new speed, that's the magnitude. The magnitude is the length or the force. So my magnitude is the length or the force. So in order to find this length right here, we could measure it, but measuring it's not very accurate. Or how would we find this length? Thank you, Micaiah. How about 400 squared plus 50 squared equals c squared, right? So what is 400 squared? Clear that. Plus 50 squared. I'm going to square root that answer, right? So about 403.1. Now, easy question. What is this number? 403.1. What is this number? 403.1. What is this number?
It's your new speed.
It's your new speed. We're actually going faster, aren't we? Even though the wind's hitting it sideways, we're actually going faster, aren't we? Okay, so that's new speed. That's miles per hour. So that's my magnitude. How about the direction? How do I find the direction? How do I find the direction? Well, I need this angle here. How do I find that angle there? I mean, I'm off north, right? North is straight up at north, and now I'm off north a little bit. How do I find that angle?
Opposite tangent.
Tangent. So I go tangent of theta is equal to my 50 over my 400. Good job, Sky. Tan inverse, right? Tan inverse of
50 over 400 degree mode, right? So I'm going to go tan inverse of my 50 divided by my 400, and I get about 7.1 degrees, or yeah, 7.1 degrees, and that's my direction. So I've got my new speed, a little bit faster. Isn't that funny how a side wind like that is actually make it go a little bit faster, but it does. And then I've got a new direction, okay? Easy, thumbs up. That's vectors. So if you take physics, has anybody taken physics yet?
No.
You're going to need to know vectors. You agree with that, Sky? Sky, you took it for a few weeks or whatever?
First month.
First month. You have to know vectors to do physics. Okay, now, second part, example 2. So, graph PQ. Okay, so I'm going to go ahead and take a look. I'm going to put this on graph paper. It might be easier if I put this on graph paper. Let's see. Why not? Put it on graph paper. So, I'm going to put it on graph paper. And P is at 2, 3. There's P and 6. 3, 6, 4. 1, 2, 3, 4 is Q. Right?
Now I drew it in this direction because it says PQ like this, so I know it's going in this direction. From P to Q, now let's call this vector V.
Vector V. So I'm going to call this vector V, and I'm going to change it to a component vector. Now, a component vector starts at the origin. So a component vector starts at the origin.
So what I want to do is take this vector and just put it here. Because all we care about is two things. We care about magnitude, length, and direction. So if we take it and move it here, we'll maintain our length and we'll maintain our direction, right? We'll just say, let's start here, let's start here. So we're going to move the vector.
We're going to move it to here. We're going to move it, and then it looks like it's up 1 over 3, up 1 over 3. Okay. Now, vector V, we're going to call 3, 1. Now, that looks like a point, doesn't it? 3, 1, you say, wait a minute, Dad, that's a point. But we already know that if it's a component vector, where its endpoint is always at 0, 0. So when you see a vector in component form, you know this is where that head is, and it starts 0, 0. Does that seem easy? These two are the exact same vectors, because if all we care about is magnitude and direction, we've maintained length and its angle, haven't we? But we just put it at the origin, okay? Okay, now, if I wanted its magnitude, what's the magnitude? So if I wanted the magnitude of this thing, okay, magnitude, how could I find out what the magnitude? First of all, what is the magnitude? What is the magnitude? It's the length. Okay, Wakaiwa, how do we find the length again? Yeah, so if I want the length of the vector, we're just going to go 3 squared plus 1 squared equals c squared, which is the square root of 10. Now you'll see this symbol in most books. Absolute value, right? This means magnitude. So when you see the absolute value, it means magnitude. What does magnitude mean? It means length. And how do you find the length? The magnitude is simply going to be the square root of x squared plus y squared. That's all it is. So when you see the word magnitude, it means length or force, right? How strong was Morgan? That's a force or a length, right? Because think about this, Morgan. When you gave it, really you gave a length, didn't you? No, think, okay. So you put it together. When you got a force, which give you a length. They're the same. When you give a big pull, you could use a lot of force, and you got a longer length. So the word magnitude means
length or force, depending on that application, okay? So if you want the magnitude, you want the length, which is also a force. If I drew this twice as long, it'd be a stronger force. Got it? It's that easy. It's that easy, okay? Now, so the magnitude and direction. So here's the thing. We know the magnitude of V is the square root of 10, and its direction is the point. The direction's easy. It's just the 3, 1. So in vectors, if it's coordinate vectors, meaning x, y, if it's coordinate vector, then the direction is just the point, because you know how to get there, right? Go to 3, 1, there you are, right? So let me put my point back up there. So here's my vector, okay? I know where it's going. Where's it going? It's going to 3, 1. That's its direction. I know its length, but how strong is it? Square root of 10. Thumbs up? Okay. Turn the page. Okay, now, easy. Easy, easy. Draw. Okay, well, got my ruler. I want to draw V plus U. Head to tail method. Okay, so I'm going to go ahead, and that's about 4. So I'm going to go down here and draw this about 4. Same direction. There's my V. Okay, so I just copied it. I just copied it. Boom. Okay. And I want to add U to it. And it says head to tail method. So a head to tail method would be to draw it here, right? I didn't know this. So I want to add them. So I'm going to take V, I'm going to add U onto it. So I'm going to put U right there. Does that make sense? So I'm going to put U, I'm going to use my ruler, find out how big it is. Okay, and it's about 2.8 maybe. Maybe. Did you get 3? 3 seems easier. Okay. There's U. But that's not my answer, okay? Where is our true path, our resultant vector? Where's our true path? Our true path is really here. That's my resultant vector. That's my V plus U. So Morgan poles, Lennon poles, this is where sky goes, okay? Now that's not very applicable because really if they're both pulling at the same time, then we do it as a parallelogram. So as a parallelogram, we just did the head to tail method. As a parallelogram, I'm going to draw this differently. I'm still going to draw V. And V was, what do you say, about 4? V is about 4, so I'm still going to do V is about 4. And U, we say about 3. So this is the way you guys actually pulled. Morgan was here, Len was here, here's Sky. And they both pulled, and basically Sky is going to go this direction here, correct? Does that make sense? You both pull it here and here, so you're going to go here. Does that make sense where I'm going to go? So if we build a parallelogram, we get the result vector, okay? So if I build a parallelogram out of this, I'm going to go and take my V, which we thought was, Sydney, would you say it was 4? And that was about 3. So here's my, okay, do you see a parallelogram? I see a parallelogram. So then the resultant vector is here. Now, this is my resultant. Okay, which way do you like better? Do you like drawing it head to tail, or do you like drawing a parallelogram? They both give the same result. Most people like head to tail better because it's faster. Boom, boom, done, right? Parallelogram makes more sense because you're both pulling on at the same time and he slides this way, correct? Head to tail is what you're going to see most of the time, most applications, because it's easier to draw, okay? But the airplane just doesn't go, stop dead in the air, wind blows, right? That doesn't make sense. Airplane, and it stops in the air, right? And then wind blows it off course. That doesn't happen. It happens like this, correct? But this is the easy way to draw it. Okay, now, on the graph. Oh, no, wait, we got to do this one. Draw 2v. What do you think 2v means? 2v.
Two of them.
Yeah, so let's do 2 of the v's. So I'm going to do a 4 and another 4. There's a 4 and another 4. There's a v and another v. And what about a subtract u? What do you think the minus, what do you think a subtract, what do you think that's going to subtract u? What's that going to do?
You take away about 3.
Hmm?
No? I'm wrong.
It goes in a different direction.
Yes. In fact, if it's a negative u, what do you mean by different? It's as obvious as this.
It pulls that way.
Yeah, it's going to go the
that
opposite
way.
direction, isn't it? Instead of a pull, it's a push. So if I'm going to go minus v, I'm going to go that way. Does that make sense? Just the opposite direction. It's a pull, it's a push. So we're going to go this way. And this is a negative u, and the resultant vector is right there. Boom. There's my resultant vector. There's my 2v minus u, okay? Okay, now the easy stuff. So once, and we like vectors on the graph paper because it's so much easier to draw, okay? Once it's on the graph paper, it gets super easy. It really does. So, for instance, okay, let's draw a vector v. Well, 3, 5. Come on now, where does it start? 3, 5. 0, 0. So 3, 1, 2, 3, 1, 2, 3, 4, 5. That is a vector. That's vector v. Okay. And u is at negative 3, 5. So 1, 2, 3, 4, 5. Negative 5, 3. Yeah, I said it backwards, didn't I? There you go. There is my v and my u. Now, if I want to add them, there's 2 ways to do it. Parallelogram method. I can make a parallelogram, and there's the result, okay? There's 3 ways to do it. I could then draw head to tail. So draw it up here. So I got to take this and draw it up there, okay? Get the result, okay? And that's what we do. And the third way is just add the stinkers. That plus that plus that, and you get the answer. Because we're going to add, right? So the resultant vector is just negative 2, 8. But let's draw it and see it, okay? So if I were to go ahead and do it head to tail method, I'd put u up here, and I'd go negative 5. Watch. 1, 2, 3, 4, 5. 1, 2, 3. Resultant vector is right there. But, what is the resultant vector? It's as easy as this. I'm just going to go and take 3 plus a negative 5, comma, 5 plus 3. So I get a negative 2, comma, 8 is my resultant vector. That's my v plus u. And if I wanted the coordinate of that point, sure enough, it is at negative 2, 8, okay? Okay, now, how about 2v minus u? Well, we could draw it, or what's the easy way? We could draw it, or what's the easy way? Let's double that point. Let's increase its magnitude twice. Let's double this point and then subtract that point. So, an easier way to do it, if it's in coordinates, is to take and make it a 2 times my 3, comma 5 minus my negative 5, 3. Okay, see what we got? I'm gonna
11, 7.
There you go. And so 6, 10. Yeah, you're way ahead of me. Okay, so I'm going to get a 6, 10 plus a 5, negative 3, which is a 11, 7. Yes. It's that easy. Thumbs up? Okay. Now, unit vector, okay?
So do a unit vector. A unit means make it have a size of 1. Okay? So how do you make it into a unit vector, okay? So you've got to find first the radius. So let's find the magnitude first. Because a unit vector is going to be simply my x over its magnitude and the y over its magnitude, okay? So the magnitude, what the heck? Magnitude, what the heck? Let me go back through my notes. What's magnitude? Oh, wait a minute. To find the magnitude, we did that, right? So let's find the magnitude. So the magnitude is going to be a square root of -5 squared plus 12 squared. And I get 25 plus 144 is 13, okay? Don't worry, we're not going to have homework. We're going to run out of time to do homework. I'll do that in class tomorrow, okay? So, if I want to make this vector, which is at -5, 12, and make it itty bitty bitty, it is simply going to be 5/13 and -5/13 and a 12/13. Okay, I know I'm running out of time. We got a lot to catch up on today. This last piece I'll talk about more tomorrow. How's that for a deal? Talk about this more tomorrow? Okay, so if you're taking a look at this vector, it's really itty bitty, but the length is 1, okay? We'll do that tomorrow. What do you think? Vector is pretty easy?
I know.
Not two.
And I'll stop recording.
How many